Welcome back, friends. I am your host Atharva, and we are on the Skill Raptor now. Today, we are going to discuss a very interesting open source tool which we can use for designing distribution network for pipes. So, in last lecture, when I explained a pump and a pipe simulation for a building, that time I got a very interesting query from one of the follower. So he asked me to do a video on a network, on a pipe network. So finally, I could find a very good open source software which you can use very easily. It's very easy to use, and there are a lot of versatilities with that software. So we are going to see one by one. First, I will let you know where to download it from and what is the interface, and we'll try to solve a very simple problem. And also, just to announce this, since this video is about pipe distribution networks, and there may be many people who will be interested in such kind of tools, so I will also be making this video in Hindi altogether. So please kindly watch this channel, subscribe, and also like the video if you really liked it, and share with your friends. So let's start. So the software is EPANET. So you can see EPANET directly will get, just press enter, and so I'm clicking on EPANET 2.20, and this will take you directly to this page. Just scroll it down and you can see there is a direct link to download EPANET. Also, you can get it from GitHub, and there are certain extensions. So I'm just clicking on the download EPANET. After clicking it, if you scroll down, you will get software and manuals, and also some toolkits and extensions. So you can try downloading self-extracting installation program for EPANET. This is a very easy to use software. So just click on it, download it, and the installation is very simple. It doesn't require much of extra plugins. So just download it. So now I am introducing you to the actual interface of this software. Okay, so I am on the interface of this software. You can see a lot of options on the top. So I will just make you accustomed with what exactly they are. So currently in this particular video lecture, we will be using the right half of top, that is add junction, then add reservoir. Uh, it's simple. If you just click it, it will get selected, and I will show you how to use that. Then there is one add pipe, pumps, and valve. And top of it, you have file, then edit menu. I will show you how to effectively use this edit menu in the lecture. So please kindly watch it till the end. Then view, a lot of viewing options are there. Then project. So let me just click to project defaults. Okay. So these are the defaults. So what kind of properties we want to use? So say now these are the by default values which you will see when you will add each one of the item above. That is node, elevation, then tank diameter. So 50 meter will be the tank diameter, tank height 20 meter, pipe length meter. Then the pipe diameter and pipe roughness is given, which is kind of a default. So now let me show you some more things. View and options. So this is also one of the important things to be noted. Nodes, how many nodes you want, node size. So basically this is the size. This will be the representation of how big the icon looks. Links. So links are nothing but the joining lines between the two nodes. I will show you that. Then labels, display map labels, use transparent text. All you can identify, and notations. Notations are very important, so I will select display node values and display link values, because these are very important. Whenever we are analyzing a network, so the node values and link values, they give us some information that I will explain you. Then symbols, flow arrows, and okay, let me just filled. So background is color, you can change it as per your wish, but I will just keep it white. I'm just clicking OK. Also on the project we have by default, so in hydraulics you can see there are flow units, then you can change the flow units. So for timing I'm changing it to LPS, that is liter per second. GPM is gallons per minute. So there are different flow units, according to your convenience you can change. Then head loss formula. So there are a couple of head loss formulas here. So HW is Hagen-Williams and DW is Darcy-Weisbach, and I think CM is Manning equation. So let me tell you, by default we have Hagen-Williams. So Hagen-Williams, that is HW formula. This is a more of an empirical formula which was given by Hagen and Williams. So it is mostly useful in long pipes where you are simulating a very lengthy kind of a piping system. And also this is valid only for turbulent flow. This formula doesn't give you good values or good estimates in laminar flow. So generally this is used, Hagen-Williams is used to just take a ballpark number. This may not give you exact calculation. So in general, what is recommended is DW, that is Darcy-Weisbach. So Darcy-Weisbach equation is being derived, it was derived from the basic laws by using basic fundamental fluid dynamics. So it is not empirical, and it takes in not just pipes, but it also takes in effects which you get from wall effects. Then if you're adding a pump or if you're adding a valve or there is a T, so those kind of effects are also taken into Darcy-Weisbach. Moreover, it gives very good estimates, almost within 1% error, and maybe less than that for almost all liquids, even gases, and also there is no limitation for turbulent or laminar flow. In all kinds of flow regimes, it gives you a good value. So just remember, use Hagen-Williams only when you want to just get a ballpark number, because Hagen-Williams is a easy to use equation. It is not having much of complication, so the computation becomes easy. When you want some exact values and if you are doing some serious calculations, please use Darcy-Weisbach equation. Okay, so for time being I am selecting Hagen-Williams. I just click OK. Now I will show you how to design a basic uh, pipeline system. So I am selecting from top. So this is a tank, this is a reservoir, this is a tank. So I'll just select a tank and just click. You can see a tank is, you can see a tank here. Now I'll go to nodes. Just click on the nodes. For for this tutorial, I'm doing it random. So I'm taking 4 nodes, and maybe say here I have a final node. Okay, so these are the nodes. Now I want to join these nodes and this tank with the pipelines. So let me take, I have selected a pipeline from the top. Just click on it and you will see a pencil like icon. Just join it. So I'm just joining it. Just do it one by one and carefully. And for timing, I am showing you a very small network. You can also design large networks using this, even the real life networks. So, so in your house, the water actually comes from a dam which is close to your city. So there are huge pipelines you can see running around your city or through on sidelines of the road. So that also you can actually design here. Now I have selected, I have made my network. Now let me just specify. So just double click on the tank and you will get all the specifications which are necessary for carrying out. So elevation, so let's say I will give a elevation to this tank as maybe say 100 meters, and initial level. So initial level is what your water is currently at what height. So I'm just giving it as a 2 meter height. Then minimum level below which your, say you have a tank and you have a pipe at the bottom. So below that level, your water will not be drawn out. So you have to give that estimate. So I'm just typing 0.2, it is in meters, and maximum level. So maximum level I'm giving 20 meters. So say my tank is having a height of 20 meters and diameter of the tank. So I will just give it 30 meters, say. Press enter and you can just close it down. Now let me specify the pipes. Just double click on the pipes in between and you can see um, there's a length given, then diameter given, and roughness of the pipe is also given. You can change. For timing, I will just let it be to 1000 meters. All pipes are 1000 meters and diameter 12. You have nodes. So nodes, okay, these are the nodes. So 500, I think 100 meter we have taken our tank elevation. So say I will just uh, give the elevation to this to be say 60 meters. Then there is no base demand here. So base demand means if you want to draw water out of it. Let me give this 50 meter. Then this again I will give 50 meter and this let me give it 30 meter or say 10 meter maybe, and say 2 meter elevation, and there is some base demand. So base demand is in liter per second. So let me just give a base demand of 20 or say uh, 3 liter per second. I think that will be better. Okay, now I have set up all everything, and on right hand side you can see the nodes, data and map. On right extreme right you have a browser window. So nodes will display. So I am just clicking pressure. So you can see the nodes will display the pressure, and links, which are the pipes, will display. Uh, let them display the flow, how much flow. Now go on the top and you can see a run button. That is a yellow icon having a sign of electricity or kind of lightning. So just click on it. So there are some warning messages generated. Okay, so there are some negative pressures which we have encountered. So let us see what are the negative pressures. I am just maximizing. So you can see there are a lot of negative pressures. These are because the flow of our water is very high and our diameters, pipe diameters are very less, which is 12 meters. So go to edit, select all. Now your all are selected, then group edit. This option helps you in changing the values in a one go. So diameter, I am changing it with say 100 meters for now, and let's see what it gives. I'm just clicking OK. 7 pipes were updated and click on the run. Again, the run was successful. Now you can see your all the values are in the positive and you are satisfying a demand here. Also, you can see the results. You can download the report. You can also give the graph. There are a lot of other things which you can do. Mm. Now say if I want to see what is the head loss, just click on the links, head loss. So on left hand side there is a legend given. So you can see there is a head loss. This is a very less head loss. By the way, head loss should not exceed by more than 10 meter per kilometer. So it is very less, 0.34. So this calls for changing the pipe diameter. Maybe we can put a less pipe diameter because pipe diameter is actually associated with the cost. So you don't want a very high pipe diameter. So I'm just changing the pipe diameter again, and let's see if I can do it with 50 and still I get positive pressures. Okay, 7 pipes were changed and Okay, there is a warning message. So probably there is a negative pressure. Okay, you can see there is a negative pressure on the node. So maybe I will do it 75. Just let us do it 75, 75. Okay, and let's run it again. Okay, the run was successful. Now it's better, I guess. We can supply our demand at this particular point with at a 75 diameter also. And so this is how you can actually simulate simple pipe networks. And there is actually more to this, which I will be discussing in upcoming video lectures. So I will make this lecture short so you can go back and practice. And when you are back and confident with this, we will head to our next part of learning this software. So thank you very much, friends. Please kindly like, share, subscribe to my video channel, and also share with your friends. And remember, next this lecture will also be available in Hindi. So thank you very much.